Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on water flood. And today's topic is about vertical sweep. All right, so again, I take the materials here from this very good paper. You can find it on the internet and you can download it and you can read it. So the title is Comprehensive Evaluation of Water Flooding Performance with Induced Fractures in a Tight Reservoir. It's a field case. Okay, so this topic is about vertical sweep efficiency. And yeah, we can read it together. So based on the paper, radioactive tracer logging has been used for many years to determine the water injection profile or the vertical sweep efficiency. All right. And using these surveillance tools, using this surveillance approach, we can identify or we can characterize the interlayer heterogeneity at each well in our reservoir. All right, and then further, we can identify which layers are highly absorbing for the water. And we usually call the highly absorbing layer as the thief zone. We don't like these thief zones. Why? Because they are the thief. They rob the injected water. Okay, thus we call highly absorbing layer. They will take the majority of the injected water and they will reduce the sweep efficiency. You want to distribute the injected water uniformly, vertically, but because you have these thief zones, of course you cannot distribute the water vertically in a uniform manner because they will take the majority of the water. Okay, and sometimes we also have this highly absorbing layer but with low flow capacity. They take water significantly but they have low flow capacity, and this kind of layer we can identify as water flood induced fractures. Okay, they have high absorptive capacity but they have low flow capacity. Maybe they are the water flood induced fractures and they are the source of another complication in our water flood operation. Okay, and for this kind of condition, the recommendation as engineer we can give is to perform moderate water injection rate at the injectors that have these problems. Okay, and we go to the picture here. This picture shows the typical non-uniform absorption profile of water injection wells. We have basically two cases here. The first one is peaking water absorption. And we say it peaking because you can see we have one peak here. Okay. This is the most absorptive layer for the injected water. And the second case we have is water fingering because now we have one peak, two, three, four, five. So they are like fingers. They are different, peaking water absorption and water fingering, but basically they both reduce the vertical sweep efficiency. They will reduce the ultimate sweep improvement provided by the water flood. And of course, the resulting recovery factor that you will get will be lower. Okay, so you can get this profile by conducting radioactive tracer logging, and you can characterize the interlayer heterogeneity of your reservoirs at each well, and you can identify which layers are the thief zones, which layers are, taking most of the water that you inject. And you can also identify which layers that are most likely water flood induced fractures. And from that information, you can formulate recommendation like changing the injection rate, optimizing the injection rate, or maybe shutting off your injector, or maybe performing water shut off, or maybe stimulation, I don't know, but you still need to do the surveillance. You still need to do first this logging so that you can know the heterogeneity, the characteristics of your reservoir, and you can also know the vertical sweep efficiency at each injector. All right, so I think that's all. I hope you enjoy this video. I hope this video is useful. Thank you so much for watching and see you again in the next water flood videos. Thank you.